This will be more lines and angles. We'll start with some of the more formal relationships between lines and angles. You should have drawn, this is a continuation, you should have drawn this diagram in your cipher and made a piece of patty paper to make an angle. Place the angle over your number 1. Hopefully you labeled your angles the same as mine, so when I say them, we'll be doing the same thing. So put your piece of patty paper over angle 1. Now we're going to do something really innovative here. Let's take this angle and let's slide it down to transversal. Slide it down to transversal to the other line, and oh, look! There's angle 2. Wow. Let's do that again. Folks back home. There you go. Angle 1 is this measure, this size. We copied it. Slide it down the transversal, and we see that angle 2 is the same. Wow. Okay, what do we call these two angles? Let's see. Angle 1 is upper right in the frame. Slide it down. Angle 2 is upper right in the frame. Oh, yep, they're corresponding angles. And we just figured out, or just demonstrated, that corresponding angles 1 and 2 are congruent. Who would have thought it? Well, I would have thought it. And here's the postulate. Please make note of the postulate. Let's see. If lines are parallel, then the corresponding angles are congruent. I bet there's a converse to that. Yes, there is. Can you tell me what it is? Well, here it is. If the corresponding angles are congruent, then the lines are parallel. Yes, they are. One more time. Back to the diagram and the angle. Okay, put your angle on number 3. Okay, there's number 3. That's the measure of number 3. We've copied it. Okay, twirl it around and put it on number 2 and see if it works. Oh my goodness, looky there, it does work. Angle 3 and angle 2 are the same. They're congruent. We could prove this. It would have to do with talking about the vertical angles and making a linear pair. That would get it for us. So, well, actually from the corresponding, we can say, start here. The angle vertical to it is 1. And 1 and 2 are congruent. 1 and 3 are congruent. Therefore, 3 and 2 are congruent. We've got them congruent. Just roughed out the proof. And here's the theorem. Oh, I forgot to say, they're alternate interior. I forgot to say that. Yeah, they are. Okay, see that one's, they're inside the 2 parallel lines. And they're on opposite sides. Froggy's been hopscotching. Right? Froggy puts his foot here. Froggy puts his other foot here on the other side. Froggy is a happy little frog. Alternate angles because hopscotching across. Interior because they're between the parallel lines. Not always, well, in this case parallel because that's given. If the lines are parallel, then the alternate interior angles are congruent. Is there a converse? Yes, there is. If the alternate interior angles are congruent, then the lines had to have been parallel. The lines are parallel. Back to our patty paper. Now let's look. Look at angle number 1. Put your paper on angle number 1. I wonder where else we could go to find one. Look at 4. There's angle 1. What if I twist it around and put it down here to 4? Oh my goodness, those are the same. Well, how do we name those? Okay, well, relative to the 2 parallel lines, they are exterior. 1 and 4 are exterior to the parallel lines. What about relative to the transversal? Relative to the transversal, Froggy puts his little foot down at 4. There you go, Froggy. Froggy hops scotch to the other side to 1. So they are alternate. They are alternate exterior angles, mathematicians being remarkably not special in their naming sometimes. Okay, there's the theorem. They are the same. If the lines are parallel, then the alternate exterior angles are congruent. That's true. And the converse is also true. If the alternate exterior angles are congruent, then the lines are parallel, or they wouldn't have been congruent. Okay, let's do it again. Back to our same beginning angles and lines. Now let's look at 3. There's angle 3. What about angle 2? Angle 2 looks the same, but I already did that one. Okay, angle 3. I'd like to know about angle 3 and 8. I'm really looking at this. I'm not thinking that 3 might be the same as 8. Let me give it a try. Okay, there's 3. That's its measure. I'm going to turn it around. I'm going to put it right there. Oh my goodness, I'm disappointed. You're not the same size. I wonder if there is a relationship. Well, 3, we already know, is the same as 2. And so, if 3 is the same as 2, together with 8, they make a line. They make a linear pair. And we know from previous lessons that a linear pair has supplementary angles. So what can we conclude then? We can conclude that 3 and 8 are supplementary. Okay, well, how would that be? Well, 3 is supplementary with 5. They're supplementary angles. Their total is 180. 2 and 8 are supplementary, and their total is 180. You see it, right? Okay. 3, 2, and since we know that 5 and 8 are congruent, we can do a little adding around there and get that one taken care of pretty quickly. What do we call these angles? I forgot to say what we call them. Okay, they're between the parallel lines, or the lines that might be parallel. So they're interior. What about relative to the transversal? Well, it's like Froggy's coming down here, and they're consecutive. Or it's like the angles on this side of the transversal. 3 and 4 are consecutive. They're right next to each other. And the ones that we're looking through aren't ones that, there aren't other ones on them that we're dealing with. Okay, consecutive interior angles. And again, consecutive interior angles, as we just saw, are supplementary. That is indeed true. If the lines are parallel, then the consecutive interior angles are supplementary. I wonder if there's a converse. Yes, there is. If the consecutive interior angles are supplementary, then the lines are parallel. Okay, when you're learning these, you're going to have to remember the names of the theorems and which ones are the converses and which ones are the straight-on regular theorems. It's helpful for me to remember with the converses that they all start the same direction. There's a pattern in it. On each one of these multiple theorems that we've done, the straight-on regular one are if parallel, then angles are congruent or supplementary. The converses start with the angles to the lines. If the angles are congruent or supplementary, then the lines are parallel. Okay, the regular theorem, just like alternate interior angles, is if the lines are parallel, then the angles are congruent. From lines to, you start with parallel, and you get the angle relationship. Then you would say the converse, if The angle relationship is there. If they're supplementary, if they're congruent, then the lines are parallel. It's handy that they all work the same. Makes it easier to remember when you're doing your proofs. A few examples. One of the most common mistakes that people make is in this one. Let's look. What's the relationship between the 80-degree angle and angle number 1? Since we're talking about this transversal and those purportedly parallel lines, let's just cover up the other. Now we can see that there are two parallel lines and that this is the transversal. We can see that they're consecutive, that they're supplementary. One must be 100 degrees. From there, I can go and look at it differently. So now I'll cover up this one. These lines are now the ones I'm considering to be my parallel ones, and this one is the one that I'm considering to be my transversal. So having done that, 1 and 2 are now consecutive interior angles. 1 we just saw was 100 degrees. So since they're supplementary, 2 must be 80. I've noticed that these across are the same. That's going to always happen when you have sets of parallel lines, but just be aware that there's no formal relationship between the 80-degree angle here and 2, which is also an 80-degree angle. You'll have to work yourself around to prove it every time. That since they are not on the same transversal, we don't have a special name, a special theorem for them. Here's a couple more you can look at. You can kind of do the same thing. And this one. And I have some here that you can work on to give you a hint. And I have some hints for them. So here is problem 27. Look at that. It's kind of fun. And here are some hints for doing that problem. Look at number 28 here. And the instructions are to find the value of x and y of the variables. If you're having troubles, here are some suggestions that can help you with this one. Go to number 29 here. If you have difficulties with number 29, here are some hints that might help you. Notice here we're talking about the combined angle. I'm sorry, this one. So y plus 55 is the one that is consecutive interior to 65, not just y. It's got to be y plus 55. Sometimes people get a little bit messed up on that. Notice that this one has two transversals. Here's two parallel lines. One transversal goes here, crossing both parallel lines. One transversal goes here, and you get to use both of them as transversals. The next one, marked as 30. If you have trouble with it, here are some hints. The next one marked as 31. Here are some hints. And 32. Here are some hints. Hopefully that'll help you a little bit. Now this one's a kind of fun one. See if you can figure this one out. I'm not going to give you any hints. Okay. And here are some more just to play with if you want to play with some. See how you can do. how do you know that the tabletop and the ground are parallel? Well, you can pretty easily measure this angle with a protractor. You can measure this angle with a protractor. And you can conclude that the tabletop and the ground are parallel. You can also tell because the apples don't fall off. And here endeth the lesson.